Hey, how y'all doing today? It's hot, right? So thank you all for coming into this room and bearing the heat. Hello. So this is a fun one. I do this a lot. If you've seen me talk before, I'm sorry. I'm going to do it again. But I kind of like walk into the audience. Well, that's not good. No. Okay, I'll do the short version. I go like this, and then I like do this with the cat, and then it calms me down. This is backfired. I am not calm. That did not work. So improvisation is a fun thing. I'm Myles. I work for Google as a developer advocate on cloud platform. This little line at the bottom, put this in all your talks. This is my opinions, not my company's. So we're going to start with a quick glossary because I'm going to use lots of terms. ESM, ECMAScript module. CJS, Common.js module. Interoperability. This is the ability to access ESM from CJS and vice versa. This is a really important core concept of trying to get Node and the web to play nicely together and for us to move forward in a way that doesn't, fracture the ecosystem. Transparent interoperability. This is the ability to require ESM in CJS and import CJS in ESM without having to know the type of the module. So the ability to npm install a module and then just use ESM or CJS and not have to worry about it. This is kind of how a lot of the transpiled loaders work right now. So if you use BABEL or TypeScript or Webpack, you don't really need to know the type of module that you're using. A goal is a pairing of a top-level grammar and a top-level execution model. I'll get back to that one later. Bare imports is the ability to require a module by its name. So if you ever do, like require Lodash or import underscore or vice versa, the ability to just reference it by the name of the module and not have to give the full path to things that are in your Node modules is referred to as a bare import. Existential dread. This is the feeling I get trying to get all this to work and thinking about this problem space. And, there are a handful of existential problems that we have in JavaScript, the language right now. Find me later, we can have a beer and talk about it. But how did we get to where we are today? So who remembers ES4? It never happened. But ES4 is introduced the concept of packages. These were primarily based on C++ namespaces, and the intent was to create something similar to the Java jar system. For those of you who don't know, the joke I just made was like ES4 never shipped. We went straight to ES5 from ES3. And it was ripped out of the standards track, and it was never seen again. All these ES4 features kind of just vanished. Common.js was then introduced. Members of TC39 worked on it, but it was never standardized. It was intended primarily for server-side JS. And we'll get into in a minute why this is specifically for servers and doesn't really scale to the web. And Node.js implemented a variant of the Common.js spec. Who remembers AMD? Okay, keep your hands up if you liked writing the files. It's okay, you already put them down. But AMD actually wasn't specified. It was mostly implemented in require.js. And it was more of a convention than really a standard. And because of all these different things, we had a thing called UMD that we used to package them all up so we didn't have to think about the modules. Like UMD was, I guess, like the transparent interop of 5 years ago. But ESModules landed in ECMA 262 in 2015. And at that point, we had modules. They were standardized, but they weren't anywhere. So let's go back to that glossary again. What's a loader? A loader is a generic term for a workflow. It includes fetch, transform, and an evaluation hook. These are the phases that happen when you try to load a module. And when I reference a loader, it is an implementation that does all of these things. And this is where we get into like the first really weird thing that makes things hard. Common.js technically doesn't have a separate loader phase. It has synchronous load and inline execution. When you run Node and you start a file, it just starts executing. When you hit a require, that just starts executing that file. And it does this synchronously. So when you try to load that file off the disk, it just starts executing it. And it does that through essentially the whole graph of your modules. And this is why it's not really good for the web. If you had to wait for something to go over the network every single time you hit require, and this isn't able to be done asynchronously, you're going to have a long time to wait until your first paint, which is no good. And as I said, there's no load step. Everything just kind of happens. And this is actually how BABEL originally implemented ESM. If people are from BABEL, you can find them afterwards, and maybe I'm overstretching the implementation, but essentially they took the import statements, converted them into require, and then converted that directly just into files being linked together. So the original BABEL loader was this kind of inline execution model. That was a breaking change to BABEL when they implemented the asynchronous model that's closer to what is specified. Because ESModules specify asynchronous load and synchronous execution. These are separate phases. Your entire module tree is determined first. So top-level await may change some of those guarantees. I just said there's a synchronous execution. It is possible that the actual execution of your graph could become asynchronous. That's the only way to really support it. But that's not what this talk is about. It's a whole other talk. Grab me at the party. I'll tell you all about this. This is the fun part, though. The loader itself is not specified. It's implemented by the embedder. The way in which it executes is specified. The way in which the graph is crawled and everything is linked is specified, but how you actually load all those resources is left up to the embedder. There's been attempts to specify this, both at the W3C as well as the WHAT working group, but most of these processes at this point have stalled, and it's primarily being implemented, and it may be specified in the future. So I mentioned that load phase. The load phase first goes and fetches all of the texts for all of the module graphs. So it can go, it finds all the symbols, it finds all the things it needs to load over the network, and it can asynchronously grab all of these. And you can imagine how this actually pairs really nicely with a concept like H2 push, where you can go and start grabbing everything really quickly. It resolves the specifiers within the source texts and then moves into the linking phase. For the linking phase, the module graph, all those files need to be in memory. And after they're in memory, they're executed in pre-traversal order. So this means that from the top down, it's actually going and linking your entire graph. This is important when you have things like cycles. So if you have modules that are referencing modules that are referencing modules that are, as you can imagine, it gets complicated. You don't need multiple instances of those to be executed because everything in the graph is returning a singleton when you grab a particular keyword. So when you import React in one file and you import React in another file, you want that same version of React because you need to be registering the components in the same area or things get weird. And then that moves into the execution phase, which requires your link to be completed and actually is done in post-traversal order. So it actually starts from the leaf nodes and executes all the way up to your root node. And this could almost be thought of as a little bit of an instantiation phase. So you're actually going through all of the modules that are in the graph, loading everything up into memory, creating all of those singletons so that when you eventually make a call to React later, it's ready to be used. This isn't something that Common.js ever needed to worry about because everything's just executing in line. And this is where things get weird. These two things are not interchangeable, and it can actually result in different execution order. The exact same graph defined by require and then defined by import can actually cause things to execute in a different order. And if you're relying on the order that your modules are going to execute, that can bite you. More behavior differences. The specifier resolution algorithm is also different. So TC39 leaves it up to the hosting environment how to do specifier resolution. And the specifier is the name of the module that you're loading. That specifier in the browser is a relative path to things that are on the disk. And in Node, this could be a combination of relative paths, or it could also be a bare import, as we mentioned before. So Node.js has a specific resolution algorithm for dealing with specifiers. We support bare imports, so you can import Lodash. We allow you to import JSON. We allow you to drop the file extension. That's a nice one. You can just import a file with no extension. And you can also import a directory. And those play nicely to each other because you can, name a file capability, and then that can turn into a directory with all sorts of things in it later without you ever having to refactor your code. But this isn't exactly how things work in the web. The web doesn't support bare imports. Currently, the web only supports those paths. You can only specify either absolute or indirect paths. So if you had a module that you wrote for Node that's using a bare specifier, it's just going to blow up when you put it in the browser, for now. Because there is actually a proposal, it's called package name maps, which is going to allow there to be a lookup process to actually find the bare imports that are in the tree. But it has a slightly different feature set than Node's model. Specifically, you can do bare imports, but you can also do deep module traversal by file name, so like the name of the deep import / and then some file that's deep in that tree. But you can't import directories, and you have to give the file extension. The reason for this is that you don't want to be doing multiple network calls for all of your modules. In Node, this is fine. Arguably, it can actually be a problem, but if you import a thing without a file extension, we can check and say, oh, first is it JS, okay, is it a native module, oh, is it JSON, oh, is it this thing? And maybe we're only like checking 4 or 5 or 6 different file extensions, but those hits to the disk are cheap. But you don't want to be doing that in the browser. You don't want for every single module in your graph to be making like 7 or 8 network requests, and for each of those network requests needing a server that knows exactly how to respond and then handling, 404s. So this kind of explicitness is necessary. More behavior differences. The code actually executes differently too. So we were talking about goals before, and ESM and Common.js actually run in different goals. And we talked about it before that it was a mix of 2 different things and it was kind of confusing. So let's dig into it. There's 4 types of goals. You have script strict, you have script sloppy, you have ESModule, and Node.js. And now when you start seeing these, you can get an idea of what a goal is. It's a combination of a grammar and an execution mode. So when we talk about a top-level grammar, we're specifically talking about things like strict mode versus sloppy mode. The ability to specify, like what symbols, what APIs, what is actually exposed by the language. Strict versus sloppy is able to be denoted by a pragma, use strict, which was a best practice, 5 years ago and still is, and that removes capabilities from the language. Generally, we don't want to break the language. We don't want to change the way things work. So strict mode was a way to remove some dangerous things from the language, but you did it explicitly and it was opt-in, so the chance of breaking things that had been on the web before was really low. Now, the module goal, which is different from both the strict and sloppy goal, actually has some extra grammar changes that are on top of that. For example, you can't use HTML comments. Quick raise of hands. Who knew you could actually use HTML comments in JavaScript? So you should change that, or it's going to break when you make modules. Await is a reserved keyword, and this was actually explicitly done by the committee to make sure that top-level await was a thing that could eventually happen. And these divergences may change over time. That await is a reserved keyword thing also makes it hard to use, any variable that's named await. It's not allowed anymore. So this is one of the really hard parts, though. ESModules do not have an in-source way of determining the goal. Strict mode did. You had a pragma. You could say use strict. ESModules are just code. There is no pragma. The committee decided not to use a pragma because it is a new goal. It's a new thing. It's not a progressive enhancement or dehancement. It's not new capabilities. It is its own thing. And when you're using the browser, you're using a type equals module. There's no need to have that pragma. But in Node, we have no way of really knowing. And there's also more goals that may be coming in the future that are in the standards track. And this includes binary AST, WASM. We have Lynn Clark in the audience right now who's really driving making it that you can import WASM, and that's going to be like ridiculously cool. Web packages, which if you haven't heard about it, it's really cool. When we think about bundlers today, bundlers for scripts work because you just make a giant script. But bundlers don't really work for modules because you can't just make a script that has multiple modules in it. So Webpackage is one approach that would allow you to bundle modules all together in a way that could be understood by the browser. And HTML modules are another one that would probably be pretty nice to have if you're, doing modern web dev, JSX has a lot of this kind of inline ability to make modules. So we have to pave a COWPATH. We have to think not just how do we make ESM and CJS work together. We have to think about a solution that works for every number of infinite possible future goals. And this is hard, especially when we're thinking of interoperability. So if we're loading ESM from CJS today in Node, you can use dynamic import. It returns a promise. It's not really the best way of doing it. You can't export the things that are on that symbol. But you can't require ESM, and that's because ESM has this asynchronous loader. Grab me later and I can talk more about the inconsistencies there. You can also Google, it's called zebra striping. But when you move from async to sync and then back to async, just things get weird. From CJS to ESM, alternatively, though, there's a lot of different ways that we could do this. For Node's core modules in our implementation, you can import from FS. And as of Node 10.2, which we released about 2 weeks ago, you can even do named exports from core modules. But core modules in Node have an advantage because Node is compiled and we can do all sorts of things in advance for it. And we allow you to import a thing from CJS in our ESM implementation, but not with named imports. You only get the default, and this capability makes it a little bit more difficult. The idea of transparent interop is not having to know the difference between the types of modules, but you kind of do because you only have a default, and this is one of the things that we're still trying to work out. IMPORT.META requires something that we're talking about doing. IMPORT.META is the ability to put scope things I'll talk about in a second, but IMPORT.META require would allow you to just require CJS right into ESM without having to worry about transparent interop. More behavior differences. ESM does not have a way to inject lexically scoped variables. So as we were just talking about with IMPORT.META, CJS has lexically scoped variables, and this will be another one of those times where I start listing them, and all of a sudden it makes sense what a lexically scoped variable is. In Node, we wrap every single module in a Lambda, and we inject these variables into the scope of that module for you. So these are actually not globals. They're specific to your module. They're the specific file name, the dir name, a shared instance of require, and the module that's exposed. All of these are things that we inject for you, but ESM doesn't have that. So this is where IMPORT.META came in, and it's stage 3 at TC39. It's a proposal by Dominic, and IMPORT.META allows the runtime to inject variables into the module itself when it's executing. So inside of your module, you could say IMPORT.META URL, and that's a replacement for the file name or dir name. And that's somewhere where we could hang require, for example, to essentially have a backdoor or an injection to allow you to get those CJS modules in without having to worry about transparent interop. And as I said, you can use ESM in Node today, but it is behind a flag, experimental modules. And I highly advise you not to use it in production because everything could change from under you because we're still trying to figure it out. But a quick summary of our current implementation, everything is behind a flag. We have support for named exports for core modules. ESM files need to use the MJS file extension, and we're going to need that no matter what. Even if we allow JS for ESM, the ability to do an out-of-band solution to say, hey, this thing's an ES module is necessary. Even to just say node thing.mjs. That's our way that you're able to just boot into an ES module no matter what. We have support for bare imports. We have support for transparent interop in ESM without named exports, but no support for transparent interop in CJS because with an async loader, it's currently not technically possible, but we're exploring options at the standards bodies of how we could do this in a way that would actually work. And we also have support for dynamic import in both ESM and CJS. You name a module in dynamic import, it returns to you a promise to resolve that. Top level await will make this really great in ESM, but currently the top level await spec is not targeting the script goal, so it's not an enhancement that would ever be available in CJS. We also have support for IMPORT.META, but currently we're only exposing IMPORT.META URL. And some of the decisions of this implementation has made some people grumpy. And in response, we spun up a Node.js modules team. And this is really cool. We made it open and 42 members signed up in the first week. This included representation from at least 10 countries, including Canada, China, Germany, Israel, Italy, Japan, Nigeria, the United Kingdom, and South Africa. Oh, and the US. We also have representation from 10 different corporate organizations, including Airbnb, Applet Tools, Bloomberg, GoDaddy, Google, Groupon, IBM, Microsoft, Mozilla, and Nearform. And NodeSource. I'm off by one on all of these. It's a big problem in technology. We have key stakeholders from at least 14 open source organizations and programming platforms you may know, such as Angular, Babel, Bluebird, Fastify, LibUV, jQuery, JSPM. We also have Lodash, Meteor, NPM, Polymer, Tap.js, and V8, and Webpack. But as you can see, we've got a lot of people who are working on all the tools that we're using right now, trying to work towards consensus, trying to make sure that this is happening. And we also have representation from 3 of the major standards bodies. We have people who do work at TC39, people who do work at What Working Group, and people who do work at W3C. This one was really easy because there's only 3 of them. But we're all really hard at work on this problem. This is a really, really hard problem. And doing it right is this kind of existential thing. If we do it wrong, we could create this irreconcilable schism in the community. And we all take this really, really, really seriously. And I know that probably every single person in this room is worried about this being done right. And the whole purpose of this talk, I was hoping to kind of just show under the hood a little bit of all the things that make this really hard and really weird and really tough. But I also wanted to reinforce to all of you that all those people, all those 42 people from all those companies, all those projects, all those standards bodies, we're pulling our hair out. We are working really hard, bi-weekly meetings, giant threads, you can't even keep up, trying to bash out a solution so that you can just keep writing code and not have to worry about this. And I really hope, in the next year and a half, we'll be able to ship something. My dream is that you can npm install something and just run it in the browser or just run it in Node with absolutely no build step, which would be, in my opinion, absolutely amazing. And with that, here's a surfing dog. Thank you very much.